Welcome back. Now we stopped at multiplying this matrix by a constant and then subtracting and getting this result. So now that we have gotten that, let's see what other things can we do. What other things can we do when we have matrices? So we have talked about addition and subtraction like that, and we have even talked about multiplying by a constant already. So the next thing I want to talk about now is multiplication of matrices. I gave a rule the other time. I said they must be of the same dimension before you can add or subtract. But for multiplication, it's not like that. They don't have to be of the same dimension before you can add or subtract. So for multiplication, what's the rule? The rule is that if you are performing A times B, then A is of dimension n by n, and B is of dimension P by Q. Let me change my marker. So I want to do A times B. So A is of dimension m by n, and B is of dimension P by Q. So the rule says that before A times B can be possible, then n must be equal to P. Look at that. That is, the number of columns of the first one must be equal to the number of rows of the second one. If you are joining us already, please pay attention. And so the number of columns in n here must be equal to the number of rows of the second one. That is why the reverse may not be possible. That is, B times A may be impossible and A times B is possible. That's because if you are talking about B times A now, you'll be dealing with Q and M. Q and M are not supposed to be the same necessarily. They are not necessarily to be the same before A times B will hold. The only thing that can be the same is what N and P. That must be the same rather. So N and P must be the same, and the number of columns of this one must be equal to the number of rows of this one before you can actually multiply. So what I'm saying is that a 3 by 2 matrix can be multiplied with a 2 by 3 matrix. This is valid. But a 3 by 2 matrix cannot be multiplied by a 3 by 2 matrix. This is invalid. Why? Because the number of columns here is 2, but the number of rows here is 3. So they are not the same thing, so it cannot be done. For this one, the number of columns here is 2, and the number of row here is 2. So 2 and 2, so they are the same like that. Now, I think another thing that should also guide us when we are multiplying is that whenever you are multiplying such a matrix like this, it appears that these two things that are the same, they are given up. Then the dimension of your new matrix will be this and this, which is what? 3 by 3. Which implies that if let's say I multiply a 2 by 7 matrix, 2 by 7 matrix with, of course, that will be 7 by something, 7 by 5 matrix. What will I get at the end of the day? I will get what? I will get 2 by 5 matrix. 2 by 5 matrix. That's what I will get. So let's see how multiplication works. Let's take samples. Let's say we have matrix A. If you have matrix A to be 6, 1, 3, 4, 2, 0. Now, this is a what? A 3 by 2 matrix, 3 rows and 2 columns. which implies that the matrix that I want to choose next must be a 2 by something matrix. So B, let me choose a 2 by something matrix. Let me say we have 3 0 1 1 and 2 5 3 6. As you can see, this is a what? A 2 by 4 matrix. And this is a what? A 3 by 2 matrix. So at the end of the day, what kind of matrix we have to produce? This one is 3 by 2, and this one is 2 by 4. So at the end of the day, what will I produce? I will produce what? 3 by 4 matrix. I'll produce a 3 by 4 matrix. So let's see how it goes. Let's see how it goes. Now I said it that multiplication is definitely like you are opening a bracket. So this thing I want to do here is just like I want to open a bracket. Now let's see how it goes. I will use the first row to multiply the first column here. I will use the first row also to multiply the second column. I will do it for every column that I have here. The same thing for every row here. I will repeat it. Just like look at this. If I have x plus y multiplied by x squared plus x plus 1. What will I do? I will pick x. I will use it to multiply this through. I'll say x times x squared plus x plus 1 plus, and then I will use this y times x squared plus x plus 1. You can see what I'm doing. I'm just picking each element to multiply this, each element to multiply this. So that's the same thing we'll be doing in matrices as well. Now, for this question now I want you to pay attention to something. You know, I said we'll get a 3 by 4 matrix, 3 by 4 matrix, a 3 by 4 matrix. That is, there will be row 1, row 2, row 3. Then there will be what? Column 1, column 2, column 3, column 4. So elements will be belonging to rows and columns in this place. So for row 1, column 1, now I want you to take note of that. Row 1, column 1, row 1, column 1. Now, before I proceed into multiplying this, let me quickly show you something. Let me write something here. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T. Now, what am I trying to do here is that I want to familiarize us with locating elements in a matrix. If you are given the row and the column that we are using. Now, how many rows do we have here and how many columns do we have here? Let's count it. We have 1, 2, 3, 4. 1, 2, 3, 4, 5. So we have a 4 by 5 matrix. Now, to locate a particular number, we'll say, let's say we are looking for row 2, column 4 now. Row 2, column 4, there's a particular letter that belongs to that place. So we'll count here 1, 2. So this is the row I'm going to. This place is where that thing will be. Now, since they say it belongs to column 4, then I'll start counting 1, 2, 3, 4. So I is that thing that belongs to row 2, column 4. Let's say we want to pick row 4, column 5 now. Row 4, column 5. Row 4, column 5, that's 1, 2, 3, 4. This is my row 4. So where does column 5 fall? 1, 2, 3, 4, 5. So T is that what? T is that letter that belongs to row 4, column 5. So that's how you pinpoint. So you can also use this to practice on how you pinpoint elements that belong to any position in a given matrix. So why did I just teach you this now? You'll see the usefulness now when we want to multiply. So let us put our bracket out. So the first element here belongs to us, row 1, column 1. Don't forget we are getting a 3 by 4 matrix. So we will have element that belongs to row 1, column 1. Now, the first thing that you said row 1, column 1. This implies that you will take everything in row 1 to go and multiply column 1, because this place, everything that belongs here, the only element that belongs here is the element that belongs to row 1, column 1. Then what will give you that element is multiplication of row 1 of the first letter with what? Column 1 of the first of the second one I want to multiply. So A times B is what we are doing. So we have, but now again, position also comes in place. Whichever one is the first, for row 1 now we have 6 and 1. We have the first number, we have the second number. For column 1 here, we have the first number and we have the second number. Now, first number will go with the first number, and second number will go with the second number. That's the rule. So let's see what we are saying. So 6 and 1, 3 and 2. So that will be 6 times 3, that's 18, plus 1 times 2, that's what? That's 2. Now I'm done with row 1, column 1 like that. If I move to this next stage, I'm on row 1, column 2, row 1. I'm still on row 1. So anytime I move, I'm still moving on the horizontal line, I'm in the same row. But once it is changing vertically, then I'm in different columns. So if I move here now, I'm still in the same row, but I've changed to another column. This is what? Row 1, column 2. So for row 1, column 2, that shows that I'm still using row 1 from this place. But I'm picking column 2 here. That's what it means. So this is what? 6 times 0, which is what? 0, plus 1 times 5, that's what? 5. First, second. Let's see again. If I move here now, 6, 1, this place is row 1, column 3. So row 1, this is column 3 here. So we have 6 times 1 is 6, plus 1 times 3 is what? Is 3. Next one, we still on this row 1 because I'm still on row 1, but now column 4. So this is 1, 2, 3, 4. This is column 4 here. So 6 times 1, that's 6, plus 1 times 6, that's 6 as well. So I'm done with row 1 like that. Everything in row 1. So the next thing I will do now is row 2 then. Now, I can even change my form. I can come here. I can choose to do everything that is here already. Now, just mind you, this place here is row 2, but column what? Column 1. Which means I will pick row 2 from here. Now go to what? Column 1. That's 3 times 3, that's 9, plus 4 times 2, that's what? That's 8. 3 times 3, 9, 4 times 2, 8. As you can see, row 2, column 1, that's the position that we have here now. Let's say I don't want to continue horizontally, I want to continue vertically. All you have to do is what? Know your positioning. If you know your positioning, then you don't have any problem. So if I move downward, by the time you see that this is this is first row, second row, this is what? Third row. Now, as this is the third row, then it is still the first column. So if I'm moving down here, this will be the third row, then first column. So where are we picking the row from? We are picking the row from the first person. So since we are on the third row, then we are using 2 and 0 like that. Then we are still in column 1, we are using 3 and 2. So that will be 2 times 3, that's what? 6. Then 0 times 2, that's plus what? Plus 0. So the next one we pick now is from this place. We know that this place is what? Row 1, row 2, then column 2. So we are picking this and we are picking this. So that's 3 times 0, 0 plus 4 times 5 is what? Is 20. So let me continue now. 3 times 1 is 3, plus 4 times 3 is 12. 3 times 1 is 3, then plus 4 times 6 is 24. So for this last place now, we have 2 times 3, that's what? So we have already done that. So now we are on row 3, column 2, row 3, column 2. So 2 times 0 is 0, plus 0 times 5 is 0. So next is 2 times 1 is 2, plus 0 times 3 is 0. 2 times 1 is 2 as well, plus 0 times 6 is what? 0. So at the end of the day, what do I have here? What do I have here? So 18 plus 2, that's 20. 0 plus 5, that's 5. 6 plus 3, that's 9. 0 plus 5, 5. 6 plus 3, 9. And 6 plus 6 is 12. So here we have 9 plus 8 is 17. 0 plus 20, that's 20. 3 plus 12, that's 15. And 3 plus 24, that's 27. So 6 plus 0, this one is 0. This is 2 and this is 2. And that's the multiplication of that matrix. As you can see, I said we'll get 3 by 4 matrix. Let's see, maybe it's 3 by 4 matrix. 1, 2, 3. That's 3 rows. Confirm the number of rows. 1, 2, 3, 4. That confirms the number of rows, number of columns. So that explains multiplication. Now, if you can multiply something of this nature, then even if you have a square matrix, it is easier when you have a square matrix. Now, with a square matrix, that's where you can have operations like, let me introduce you to another thing that you can be asked in. Let me introduce another thing. Now, let's say I give you a matrix now, a square matrix now, this time around. 1, 4, 1, 2, 6, 0, 5, 1, 2. Now, this is a square matrix, a 3 by 3 matrix. I can ask you to perform some operation. I can say you should find a squared minus 2a plus 1. I ask you to find something of this nature. Now, before I proceed, since A is a matrix, you cannot add one, ordinary one, to a matrix. But there's an element that behaves like one under matrices. And that element is called the identity element for any squared matrix. Now, for this square matrix now, it's a 3 by 3 matrix. The identity element, so instead of 1, it's actually going to be identity matrix. So if you see 1 not as an element, as an element here, but if you see 1 being written alongside the matrix, maybe you want to multiply, or maybe you want to add, and you see 1, that 1 is identity element. And for 3 by 3, this is how it looks like. This is 1, 0, 0, 0, 1, 0, and 0, 0, 1. This is the identity matrix, identity element for 3 by 3 matrix. As you can see, all elements there are zeros, apart from the principal diagonal. The principal diagonal comes from the top left corner to the bottom right corner. That's the principal diagonal. So all the elements there, they are 1, except for other ones. All of them are, the remaining entries, they are 0, except for that principal diagonal. So, if you want to find something of this nature, what is a squared? Is a squared not a times a? A squared is a times a. So all you have to do is what? Compute a times a. Then multiply this a by 2. Then this one will be standing here. Then after you've gotten all these results, then you come and compute everything together. So now this is what we want to deal with now. So we'll pause this live video for now, and when I come back, then I will deal with this.